Hi guys, so I told you I was going to do it in a specific order, but I decided that I would just follow through the review booklet I'm posting. It's a huge review booklet. Um, and I'm going to, in the review booklet, it posts the answers so you can check and see. They're right at the front. You can watch how I do it with every single question after you've attempted them, or you can do it however form you want. So I'm going to start off and I'm going to break it into a few little videos. And by little, I mean not so little, but that's how it's going to go. So as usual, try them out on your own first, then come here to check and compare. So here it says, Ahmed's family went on 4 vacations last year, each to a different place in a different month. In January, they didn't go to Hawaii or Disneyland. So I go to Hawaii and Disneyland, and I cross them off in January. And you might be like, where the heck is this, Mrs. Lepp, and what unit? Remember, there's the puzzles and game unit where the first 2 questions on your diploma usually are puzzles and games. And they can be any kind of puzzle. They could be Sudokus, they could be this, they could be the ones where we've done first tic-tac-toe. They can be any of the type that we have here. They can be the ones that are sequences. They could be codes. They could be little games. So we don't know exactly what they're going to be, but we do know they fall under puzzles and games, and this is one type. So we'll do a few. So the rest of it, it says the month in which they went to Disneyland. The month they went to Disneyland. I'm using my little board at home, so this isn't as easy to write on. Doesn't contain the letter Y. So Disneyland can't contain Y. So we kicked this one out because it ends in Y. It contains Y. This one contains Y. So boom, in November they went to Disneyland. Okay. Then it says on one trip, the city and the month have the same number of letters. So we can check January has 7 letters, May has 3, July has 4, November is already done. So the only one that matches is either Florida or Seattle. Florida is 1, 2, 3, 4, 5, 6, 7. Seattle's 1, 2, 3, 4, 5, 6, 7. January's 1, 2, 3, 4, 5, 6, 7. So it could be Florida or Seattle, so it didn't really narrow it down all that much. Here it says they went to Florida after Seattle and Hawaii. So after they went to Hawaii and Seattle, they went, or Seattle, sorry, and Hawaii, they went to Florida. Well, that doesn't work because November is Disneyland. So let's try January. Seattle, Hawaii, and then Florida. Well, that works, right? So because it says they went to Florida after Seattle and Hawaii, I need to use Seattle and Hawaii first. So this one would be Seattle. This one would be Hawaii. And then this would be my Florida. Okay. So here it asks me the month that Ahmed family traveled to Hawaii. So I find Hawaii, I find my check mark, and it is May, which is B. The next one here, we have a substitution cipher is a systematic method of creating codes where one letter of the alphabet is used in place of another letter. In one particular code, the word cat can be coded for FDW, and the word desk can be coded as GHBN. An alphabetical wheel, such as the one shown below, can be used to aid the encoding of words with a substitution cipher. So here's the coding. And here it says the true statement using the same coding scheme is. So up here they give us cat, C-A-T, is the same as F-D-W. So I'm going to go to C and make it be an F. And then A has to be a D. If this is the case, then B would have to be E, and then this would be a D, E, F, and we'll see if it works. G, H, I, J, K, L, M, N, O, P. Don't want to mess around. Remember, I'm using a pad here. Q, L, P, Q, R. Got my alphabet. S, T, U, V, W, X, Y. That's promising. I'm ending on Z or Z. All right. So here it says D should be G. D is G. E should be H. E is H. And then S should be V. S is V. And then K should be N. So that's perfect. So our cipher is working. And then let's look down here. So they're saying GFY decodes to BAT. So BAT or I. So GFB decodes to BAT. G would be J. F would be I. Y would be V. So, or no, Y would be V. So that's not going to work. Let's go get J. F to D. Does F to D work? F to I. So that's going to be no good. I goes to IDV. Oh my gosh, this thing's so hard to see. So fast, F. So this would go, fast would be I. And then A would be D. And then S would be P. And then W would be T. So it's going this way. Boom. DOJ. DOJ would be G, L, DOJ. DOG, Crystal. And then G is J. Anyways, it's C. And that was confusing. All right. This one here says fill in the squares so that each digit from 1 to 4 occurs 1 to 4 occurs exactly once in each row and column. So we have to have 1 to 4 here and 1 to 4 here. The inequality symbols show the relationship of the numbers adjacent. Well, if this is less than this is less than this is less than this, and we have to have the numbers 1 to 4 in each row and column, this would be 1, this would be 2, this would be 3, this would be 4. Same way, this would be 1 is less than 2, is less than 3, is less than 4. Now, sorry, it's every row and every column. Okay, so let's look and see what we have. We have 1 here, we have 1 here, we have 1 here. We need to have a 1 here. It's kind of like Sudoku with like inequalities. Okay, let's see what else we have. We have in this row, we need 1, 2, 3, 4. We already have 3 here, so 3 is going to have to go here, and 4 is going to go here. And then we have 3, 3, 3. Then this is going to have to be 3. Why you shouldn't record at home? My husband just scared me when he came. This should be a 3. Okay, so why is my eraser not working? Okay, so this should be a 3. There you go. And then this should be a 4. And then this is missing a 2. I'm going to finish the whole thing because I want to. Which would have to be a 2. and this would have to be a 4. So your A is equal to 2, and your B is equal to 3, and now let's see what they want us to do with it. When the puzzle is completed, the sum of A and B, so we want us to sum it, sum is addition, 2 plus 3 equals 5. Now remember, when we fill this into numeric response, guys, I'm going to show you, we have our boxes here. We always fill in left to right, and we don't have to fill in every box. So this is going to be a 5 here. All right, so this one here says, each symbol represents a numerical value. The sum, so that's when you add them all up. Ooh, it's a pen, but it's not showing that it's a pen. The sum, so addition, of each row and column is indicated. Well, my eyes are immediately drawn to the 4 circles, which I'm sure yours are as well. If they sum to 20, and sum means addition, 20 divided by 4 boxes means each of these is worth 5. So we get 5 here, 5 here, 5 here, and a 5 here. Then the next thing I see here is that this row here has to add to 11. Well, I know that this one here is a 5 already, right? We said there's a, let's erase that. There's a 5 in this circle. So if I go 11 minus 5, I get 6 left over for the 3 green boxes. So I take that 6 and I divide it by 2, and by 2 I mean 3. Now I could use the eraser. And I get 2. Okay, pen box. So each of these is worth 2. So I put a 2 here, 2 here, and a 2 here. Which means this is a 2, and this is technically a 2 as well. I'm going to check 5, 6, 7, 8, 9, 10, 11. So we got 11 again, so that's good. Now I know that we have this row here. This row has to add to 10. It already has 4 in it with the 2 greens. So I'm going to go 10 minus 4, and I'm going to get 6. And now I get to actually divide it by 2. And each of those is worth 3. So 3 here, 3 here, 3 here. And then I need this to be 14. So in order for that to be 14, I just add up everything I have sitting here. So I have a 5, 6, 7, 8, 9, 10. 14 minus 10 is 4. And then this is a 4. And then this is a 4. Technically this is a 4. We don't really care. They want the value of A. So that's adding them up. So we go 4 plus 4 plus 2 plus 3. And we get 13. So the value of A is 13. And do 4 boxes. Once again. And 1, 3. Fill in left to right. Stop once you filled it in. All right. Next question. Still some more puzzles and games. So this one here says the grid shown below is subdivided into cages, each of which is 1 to 5 squares in size. Each cage must be filled with unique digits counting up from 1, and they have to be unique. A 2-square cage, for example, contains the digits 1 and 2, while a 5-square cage contains the digits 1, 2, 3, 4, 5. Adjacent squares may not contain the same number. Adjacent means beside. May not contain the same number. Okay? So, D has to be 1. It's a 1 cage. It's going to have to be the number 1. Okay? Now, if this is 1 and 3, this is going to have to be 2 or 4, right? In these 2 boxes, but adjacent squares can't be the same, so I can't put a 4 here because there's already a 4 here. So this is going to have to be a 4, and this is going to have to be a 2. All right, then we need, in this little box, we need 1, 2, 3, 4, 5. So I need 1 and 2. Can't have adjacent, can't have a 1 here, so this is going to have to be a 1. This is going to have to be a 2. And then if we look here, we need 1, 2, 3, 4, 5, right? Well, 2 can't be here because there's already a 2, so this would have to be a 2. This would have to be a 3. Then we look here, and it goes 1, 2, 3, 4, 5. Well, this can't be a 3. This can't be 2, 3, 4, 5. Let's go to this one, maybe. 1, 2. So we can't have a 1 and a 1 here. There's a 1, 2. This one we need 1 and 2, right? 1 or 2 here. This one is going to be a 3, then a 4, then a 5, and then this is going to have to be a 1 and a 2. You can't have, like, if there's a 1 sitting here, this has to be a 1, right? This would have to be a 2, and then so on, 3, 4, 5. All right. So we know A is 4. We know B is 3. We know C is 1. We know D is 1. Let me go and check and see what it wants from us. The value of A, B, C, D respectively. Respectively means in that order. So it's going to be 4, 3, 1, 1. And our numeric response box is going to be 4, 3, 1, 1. All right. So this one here says the the digits 1 through 9 are placed in the grid shown below such that each row, column, and diagonal have a sum of 50. Well, the numbers they have sitting here are 9 and 8. What I do know is that if I make this be a 6 beside the 9, I have 15 immediately and don't have enough numbers. So I like taking the medium number and trying it out first. So I tried a 5 here and then said, okay, well, 9 and 5 is 14. Well, then this would be 15. 8 and 5 is 13. This would have to be a 2. 8 and 1 is 9. So then this would have to be a 6. 6 and 5 is 11. So this would have to be a 4. 4 and 8 is 12. This would have to be a 3. And then 5 and 3 is 8. So this would have to be a 7. So I knew that this number had to be 5 or lower no matter what. So I tried 5 first. And it's a medium number. Now here it wants the values of A, B respectively. So A has to go first, which is a 7. B has to go next, which is a 1. And if I fill this into numeric response boxes, I would get 7, 1. This one says, at an elementary school, 30 students are each offered a choice of a free ticket to a movie or a free ticket to a concert. Due to other commitments, 4 students are unable to attend either the movie or the concert. The information is summarized in the Venn diagram below. Okay? So here we have possible values for A, possible values for B, possible values for C. Give you options. And then here it says, a set of values for A, B, C respectively is blank, blank, blank. So repeating up here that we at an elementary school, 30 students are each offered the choice of a free ticket or a free movie to a concert. So we could go first off 30 minus 4 and know that there's 26 students left to fill those circles, right? So we have to figure out which of the following can make 26. And remember that with filling in the B, you would actually have to subtract off of the A and the C. So one of the examples is 8, 7, and 11. Well, how does that happen? Well, if I put 7 in the middle, this would be an 8 and an 11, and that would add to 26. So that would be good. Remembering the three numbers need to add to 26. Another one would be 9, 7, and 10. So adding one more to this, taking one off of this, that would add to 26. Another option would be 6, 5, 15. That would add to 26. So that's your three options. All three would be included in the numeric response options. All right. Okay. This one says, the graphic organizer below shows the lunch preferences of students in the class of 27 students. The number of students, this is a set theory question. Number of students who liked hamburgers, but not pizza. That would be hamburgers and not pizza in set notation. So the intersection. That also means hamburgers only. Okay, so they want this piece. All right, so there are 27 students total. So if I take 27 and I subtract off the 7 who like pizza only, and I subtract off the 6 who like either pizza and hamburgers, and I subtract off the 5 who like neither of those, I'm going to get 9 who like hamburgers only. We have a word. The moment we have a word and we're arranging a word, we stack letters, remember? So we go Z, Y, Z, Z, Y, V, A. Now, we have 1, 2, 3, 4, 5, 6, 7 of them. So we're going to go 7 factorial all over 3 factorial, 2 factorial, which is 420. Now, I'm going to change it up a little bit. So if you're actually paying attention, you're going to get a different type of question here. I want it to start, not start. I want it to begin, not begin. I want the Z's to be together. How many times can you change a question? Z's to be together. So no matter what, we're dividing by 3 factorial, 2 factorial. No matter what. But we still need to make those Z's be together. So now we have to go, okay, there's 7 letters, so I'm going to have 7 blanks. Totally different question, right? This has nothing to do with 1 above. 1, 2, 3, 4, 5, 6, 7. Now the Z's have to be together. There are 3. So I'm going to hook them together. So I'm going to go 3, 2, 1. Now I'm pretending that they're totally different. And then I'm going to multiply by the other ones. 4, 3, 2, 1. And then I have to multiply it by all the ways, because I said together begin and start before, but now I just said together. If they're together, they can move. They're here, which is 1 way, or here, which is 2, 3, 4, 5. And remember, it's always 1 more than the hooked together numbers. So I would get on the top 5 factorial, 3 factorial, over 3 factorial, 2 factorial. The 3 factorials cancel, so it's 120 divided by 2, which is 60. So remember, it's the together part. So it's to be together. All right. Oops, got a little click on the click. All right. So here it says Jennifer is ordering 2 different pizzas, each with 2 toppings. 2 different pizzas. They have to be different, each with 2 toppings. Once she chooses 2 toppings for the first pizza, she does not want to choose either of them again for the second pizza. So not again for the second pizza. Toppings include pepperoni, ham, bacon, green peppers, mushrooms, pineapples, tomatoes. The number of 2 topping pizzas that she could order. So now some people will go, oh, okay, I can do this, then this, or this, then this. This is giving those toppings order. The moment you use those blanks, you're saying, well, I have to put this one first, then this one. Does the order of the toppings make a difference on pizza? No. So actually, we're going to count the number of toppings first. There's 1, 2, 3, 4, 5, 6, 7. And we are going to go 7, C, 2, because order doesn't matter. So we need to pick, once she chooses 2 toppings, so we're ordering 2 different pizzas. So we don't want this pizza or this pizza. We want this pizza and the next one. So we're going to multiply. 5, choose 2. And that gets us 210 because we want both pizzas. We don't want just one or the other. And so that's C. Remember, order doesn't matter. It's a C. So here there are 9 grade 12 students and 6 grade 11 students that want to be on the Foreign Exchange Planning Program. Foreign Exchange Planning Committee. So there are 9 grade 12 and there are 6 grade 11. Which is 15 total. All right. The committee must consist of 4 people with a grade, must consist of 4 people. With a grade 12 student as a president, a grade 11 student as a vice president. Okay. So we need a grade 12 president. So we're going to do 9 C1 times a grade 11 vice president, 6 C1. That didn't change when I paused it to talk to my child. 6 C1. Then the last 2, because we need 4 people, don't matter. I've used up, of the 15, I've used up 2. So it's going to be 13 C2, which equals 4,212. All right. The next one comes from probability. So here we have the probability of A is 5/17. Probability of B is 6/17. Probability of A and B is 3/17. Then the probability of not A or B, so not in the snowman. So let's draw the snowman first. Ooh. Changed. Yeah, awesome. How straight this is with my board. All right, so in the middle, we have 3/17. Then in A, we need to have 5/17 in all of A. So we do 5/17 minus 3/17, and we get 2/17. And then in B, we have 13/7, or sorry, in B we have 6/17. We already have 3/17. So we have 3/17. Now when we add them up, we need common denominators, which we already have. 3 and 3 is 6, and 2 is 8. Now, probabilities of Venn diagram, which is what this is, probability of Venn diagrams add to 1. So we technically here are going 1 minus 2/17 minus 3/17 minus 3/17, which equals 9/17. Now I want the nearest hundredth, 100th% nearest hundredth. So I'm going to do 9 divided by 17, which is 0.53. It has to start with a 0 when you're doing numeric response because there is no decimal in the first box. It has a bubble, so you literally can't do that. Okay, the next one. The graph of several functions are shown below. If a graph is selected at random, then the odds in favor of selecting a graph, odds in favor, whatever comes after this comes first, odds in favor of selecting a graph that is a polynomial. So we need a polynomial first, because odds in favor, not polynomial second. This is coming from the probability unit. And odds always add to total. So this should add to 6 graphs before we reduce it, if we can. All right, this is a linear. It's a polynomial. This is a cubic. It does that S curve. Look, this is a linear with a negative leading coefficient. Remember that? And negative y-intercept. Negative a, negative d. This is a cubic with a positive leading coefficient, degree 3, polynomial. This is a logarithmic graph, so not a polynomial. It's an exponential graph, not a polynomial. This is a sinusoidal graph, not a polynomial. This is a quadratic graph, degree 2, positive leading coefficient, it's up on the right. It is a degree 3, or degree 2. So it is a polynomial. So we have 3 polynomials and 3 not polynomials. When we reduce that, it's equally likely. It's 1 to 1. Now the values of A and B is blank and blank. I should say R. Okay. There's that. So that's from the polynomial unit, but also the probability unit, so you see how they can hook units together. So here we have the region of a Venn diagram shown below represents the number of people that prefer archery, A, badminton, B, curling, C. Now here it says, it looks like a blatant 3-circle Venn diagram question. And it is a probability though. So we're going to need it over total. Oh my gosh. Let's back that up. Let's back this up again. Clicking does anything. Does clicking change it? Nope. Alright. So what's the probability to the nearest hundredth that the student prefers archery and badminton, but not curling? Archery and badminton, but not curling. So we need archery and badminton is this eyeball. Remember the and is the eyeball, but not curling, so not this one. So it's 1. So probability, archery and curling, but not, nope, badminton, but not curling. Equals 1 out of total. So we have to add them all up. So it's going to be 4 plus 1 plus 2 plus 7 plus 5 plus 6 plus 3. And we get 28. Now it doesn't say to the nearest hundredth percent, it says to the nearest hundredth. So I just divide them out. 1 divided by 28, and I get 0.04. Okay, 0.04. All right. The next one. Shuffling my papers here. Next one is a survey of 250 students. So that's the total. Revealed that 100 students like to play Pokemon Go. So if 100 like to play Pokemon Go, 150 do not like to play Pokemon because they're complements of each other. So here they want the probability that the students don't like to play Pokemon Go. So it would be 150 out of 250 divided by 50, and I get 3 out of 5. Next one. A survey of 150 people at a resort found the following. 80 preferred skiing, 90 preferred snowboarding, 30 neither preferred skiing nor snowboarding. Okay, I'm going to read the question. You have seen these numerous times. I've told you that whenever they give you each separate and the neither and the total, you can find the middle. And we've practiced these over and over and over. As I told you, these come up all the time on my tests and on everything. So we have options. We have skiing, and we have snowboarding. Okay. So we need to find that middle piece. So if we go 80, people who like skiing, and we add to it the people who like snowboarding, and we add to that the people who like neither. People putting tickets into a hat, remember? That gets us a total of 200. However, we only have 150 participating. So if I subtract the 150, I get 50 people who put in tickets for skiing and snowboarding. So I put a 50 in here, and then I can subtract. Skiing is 80, so the whole circle is 80. It doesn't say 80 only. If it said 80 only, I'd put an 80 here. But skiing is 80, so that's 30 who like skiing only. 90 like snowboarding, so it's 40 who like snowboarding only, and 30 on the outside. Now we can read. The probability, so that's has to be over total, to the nearest hundredth. It doesn't say hundredth of a percent, it just says nearest hundredth. The randomly selected person prefers skiing, but not snowboarding. That is a fancy way of saying skiing only. So if it's skiing only is this 30 right here. So it's going to be 30 over total. Total is 150. Remember how you write these out? It would be probability skiing, but not snowboarding. And when you do these, whatever gets written beside the word probability goes in the numerator, and then the total always goes in the denominator. That's how we get the 30 over 150. Now when we divide those out, we get 0.20. What you say? All right. Now here we have a jar. It contains 5 blue marbles, 3 green marbles. So 5 blue, 3 green, 2 yellow, 10 total. John randomly selects 3 marbles, one after another, without replacement. Without replacement or with replacement, when you're pulling out more than one object, then it's independent or dependent because you have to use an and. So this would be dependent because it's without replacement. This comes from probability. Now we need 3 marbles, one after another, without replacement. Let's see what they want us to do with those 3. How much nearest hundredth that all 3 selected marbles are blue? So we want the probability of a blue and a blue and a blue. It's not or because we want 3 marbles. sequence, and it's independent or dependent. When we take out more than one object and it's using and, remember ands on the formula sheet fall in the independent dependent stage. So we want probability of blue, the first blue, which would be 5 out of 10. And the next blue, 4 out of 9, because we're not replacing it. And the next blue, 3 out of 8. And we multiply those out, we get 0.08 to the nearest hundredth, which is B. All right, and we have number 12. An executive committee consisting of a president, secretary, treasurer. Wow, we are giving these guys jobs. When we give these guys jobs, it is a permutation. Formed from a group of 9 students. Bottom is total, no restrictions. So I'm going to get 9, P, 3, no matter what. Boom. That's my bottom. Total, no restrictions. I know it's a P. Give them jobs. Let's read the rest. The probability to the nearest hundredth, not percent, hundredth, we're just going to divide, that Victor and Niabal are on the committee. Victor and Niabal are on the committee. So we need Victor, Niabal, and one other. So we can go, we need Victor, Niabal, and one other. So that's 3 people total. So we do 3, P, 3. Which gets us 0.01. Wait a second. It's Victor and Nibal. There's only 2 of them. Check that. Ah! That's not right. I need to pick Victor and Niabal first. So we're going to go to aggressively thick marker. 2P2. That's picking Victor and Niabal. And then we still have to pick 1 more. But from how many? Well, if there was 9 total, there's now 7. So we chose from 2. So these 2 have to be picked for those 2 jobs. 2P2 times 7P2, which is 0.03. All right. Here we have 4 teams have advanced to the semifinal round. Oh, I think I skipped the page. Nope, I did not. 4 teams have advanced to the semifinal round of the Tiddlywinks tournament. The Knights, the Bulldogs, the Wolverines, and the Titans. The Knights have a 60% chance of beating the Bulldogs. Oopsies. Beating the Bulldogs. So Knights winning. They have a 60% chance. And then Bulldogs winning is a 40% chance. So we would have 60 here. And we would have 40 here. Okay, then it says 30% chance of beating the Wolverines and 80% chance of beating the Titans. So the Knights have a 60% chance of beating the Bulldogs. And then a 30% chance of beating the Wolverines and 80% chance of beating the Titans. We'll deal with that in a second. The Titans and Wolverines have a 50-50 chance. So 50%, 50%. And then here it says the expression which represents the probability of the Knights becoming the champions. So we could have, okay, what if the Titans win? If the Titans win and they have 20% chance of beating the Titans. So that's 0.5 times 0.2. So let's say the Titans win. The Titans win, it would be 0.5 times 0.2. If the Wolverines win, it'd be 0.5 times 0.3. Oh, 0.8. Where am I getting 0.2 from? 80% chance. 0.8. You're all like, what is she saying? Is she crazy? So their chance of winning the Titans is 0.8. The chance of winning the Wolverines is 0.3. And then we have 60% chance of beating the Bulldogs. So it's going to be this one. Because they had to beat this one and then these, either one of these. So they have to beat the Knights. The Knights have to beat the Bulldogs first, right? And that's 0.6. And then they have to either beat the Titans or the Wolverines. In order to beat the Titans have to win, which is 0.5, and then the Knights have to win, which is 0.8. And then if we have the Bulldogs, it's 0.5 times 0.3, which is C. All right. Do these last two, and then I'll take a break till tomorrow. So we're going up to multiple choice 9. So we have a high school football team has a season record of 11 wins and 5 losses in the playoffs. So they played 16 total. They must win all 3 of their games to become champions. The team has already won their first playoff game. Okay. If the team's past performance predicts their future chance of winning, then the probability they will be champions. So they need to win their next 2 games. So probability of winning times probability of winning. And their probability of winning is 11 out of 16. Because they already won the first one, so they only technically need to win 2 more. 11 out of 16 times 11 out of 16 is 0.473. And here we have a group of 100 pet owners is surveyed about the pets they own. The results are summarized in the Venn diagram shown below. The probability that a randomly selected pet owner does not own a dog is. So they can't own a dog, which means they own a cat or nothing. Not just a cat. So it's going to be 35 and 32, which is 67 out of 67, 76, 80, 100. Which is 0.67, and there's a typo. Should be 6. So let's see. One more probability. So I'm getting the probability out of the way first because I know people forgot about probability and how to do it. But I'm going to try and finish this in the next 2 days, go through this review. And then we're going to go into some other review too. So here, if the probability of winning a game is 0.14, then the odds against winning means winning comes second and the complement comes first in simplest form. So remember probability of, oh, that's 0.14. Goodness, how was that? The probability of not winning is its complement, which would be 100 minus 0.14, which is 0.86. So we're going to get 0.86 dot dot 0.14. Now I told you you can type this in your calculator. 0.86 divided by 0.14. I'm just going to put it back in that order. Just typing it in. It gets you 43 over 7, which is just 43 to 7. And here it wants the values of A and B respectively, so it needs to be 4, 3, 7. You know what? I'm going to go till it equals an hour. So here we want the non-permissible values. Non-permissible values of division is here, here, and here. It's the difference of squares. So I'm going to get x plus 3, x minus 3. This one is going to result in x plus 2 can't equal 0. X can't equal negative 2. This is going to result in x plus 3 can't equal 0. X can't equal negative 3. This one is done already, so I have to do this one. X minus 3 can't equal 0. X can't equal 3. So it's negative 3, positive 3, and negative 2. See? So they want the perimeter. So dimensions of a rectangular fence. Rectangular represented by the rational expression is shown in the diagram below. The perimeter of a rectangle. So perimeter equals 2 lengths plus 2 widths. So we are going to get 2 times 2x minus 1 over 5 plus 2 times x plus 2 over 3. And when you're multiplying fractions, numerator and denominator. So I'm going to put ones underneath so I remember to multiply properly. So you're going to get 4x minus 2 over 5 plus 2x plus 4 over 3. In order to put them together, they need common denominators. So you're going to multiply this one by 3 over 3. Multiply this one by 5 over 5. And so we're going to get 12x minus 6 over 15 plus 10x plus 20 over 15. Common denominator means we can write them all over it. So we get 12x plus 10x is 22x. And because it's a plus sign, we don't have to distribute. If this was a minus, it would have to go to both. But because it's a plus, we don't have to distribute it through. So 12x plus 10x is 22x. Minus 6 plus 20 is plus 14. So it's A. And the next one, it says pre-simplified the expression x squared minus 2x over x squared minus 4 divided by x minus 4 over x plus 2. Her work is shown below. We rewrote the question. This one she took an x out, was left with x minus 2. X minus 2, x plus 2 is true. Division of x minus 4 over x plus 2, that's true. The next step, I flipped these, but kept the left-hand side the same, which is very true. So When we go through a step and we agree with that step and we say everything is right in that step, we put a check mark beside it. Okay? So this step here, perfect. I like it. This step here, perfect. I like it. This step here, x minus 2, x minus 2, x plus 2, x plus 2, x, that can't cancel. This is connected, right? Totally connected. So if those are connected, then you say, nope, can't happen. And you say, okay, it's going to be x over x minus 4, technically. Next off, you can't get this equal either. But this is the first error. So if you tell me they errored between here and here, which is people would always tell me, they errored between step 2 and 3. If they error between step 2 and 3, it's always the last step that they error in, because this one was totally right. They errored between these. So they errored in step 3. Step 3 is not right. Step 1, touched, perfect, minus touched, perfect, gold. Step 2, perfect to gold. Step 3, error. So the first error is in step 3, which is C. All right, still not a minute, so I'm gonna keep going. I'm still not an hour, so I'm gonna keep going. Here we have to add. We have to make common denominators. So we get 2 over x, and when we're adding, we just simplify our denominators. We don't care about our numerators. So we have x plus 4 on the top of this one, and then the bottom, take an x out, and we're left with x minus 3. In order to add, we need common denominators. So they both have an x, but the right-hand side has an x minus 3. So I'm going to multiply this one by x minus 3, and this one by x minus 3. So we distribute, and we get 2x minus 6 over x, x minus 3, plus x plus 4 over x, x minus 3. And we have a common denominator of x, x minus 3. And we can rewrite our numerator altogether, 2x minus 6 plus x plus 4. If with subtraction, we have to make sure we distribute. And so we get 2x plus x is 3x, minus 6 plus 4 is minus 2, all over x, x minus 3, which is the best simplified form, but it looks like they distributed them back together. So they got 3x minus 2 over x squared minus 3x. I would personally stop here, like I said yesterday, which is D. This one here says this expression can be simplified to this, where a, b, and c are single-digit numbers. In the expression ax, bx plus c, a plus b plus c is. Now this one actually has brackets. Yesterday's didn't. So we have 15x, which can go in their own brackets because they are singles. And then we have 6, and then x plus 2 when I take the 6 out. So technically this one's just 15, 6, and 2. But we have to watch ourselves because it's in the simplified expression. So the 15 and the 6, I can actually take a 5 out. So 15 divided by, sorry, I can take a 3 out. 15 divided by 3 is 5. 6 divided by 3 is 2. So now the actual answer is 5, 2, and 2. So you have to watch yourself. You have to simplify. It's very easy to fall to that. Okay? And 5 plus 2 plus 2 is 9. This one here, the equivalent one, remember they have to give you a piece to get an equivalent. So here they have this 6. This is a minus 6. I need it to be a minus 12. Or it was a minus 12, sorry, and it became a minus 6. So how do I turn this into that? Well, I need to divide the top and the bottom, because when I do equivalence, it has to be the top and the bottom multiplying or dividing. I have to multiply the top, divide the top and the bottom by 2. So I'm going to get 2x divided by 2 is x. plus 4 divided by 2 is 2, over 6x squared divided by 2 is 3x squared, minus 12x divided by 2 is minus 6. So they want A, B, C respectively. This is A would be 1, B would be 2, C would be 3, so it's 1, 2, 3. Oh, this would actually be a plus sign. That's an oopsie. Or B would be negative, which is a problem. All right. This one here we haven't talked about, so we're going to skip it, and it's 1 hour anyways. So we're stopping at numeric response 15 and multiple choice 13 for today, and then I'll finish the other part up tomorrow. And then we're going to move on to other stuff. Perfect. Have a good night.